So today we're going to cover Chapter 5, Section 4, and we're going to talk about isosceles and equilateral triangles today. So the first thing we need to do is identify the different parts of the isosceles triangle. Now, when you have an isosceles triangle, remember that you have at least two sides the same, and the two sides that are the same are called the legs of the isosceles triangle. The side that is not, the two sides that aren't congruent, so that other side is called the base side, or the base. The two angles that are opposite or across from the legs are called the base angles. So this would be a base angle here as well as here. The other angle up at the top that's not one of the congruent base angles is called the vertex angle. Now, keep in mind that sometimes your picture is not going to be nice and pretty and sitting on the base. They may make it upside down. Just remember that the base is going to be the side that's not congruent. So the legs always have the two congruent marks. So this would be a leg, that would be a leg. And then the side that does not have the congruency mark is called the base. And then the two angles that are across from the legs, again, these are called the base angles. So the base angles are in blue. And again, this angle up here at the tippy top, this is called my vertex angle. So just remember that when you're looking at some of these in the homework, you may have to turn them so you can see where the isosceles triangle, where the congruent sides are, and where the base angles are. They will not always be sitting right on their base, so just be careful. All right, next we're going to learn a theorem, and this is called the base angles theorem. And what this one states is that if two sides of a triangle are congruent, then the angles opposite them are congruent. So you'll start out by being given that AB is congruent to AC, and then you can conclude that if you have two congruent sides, then you're also going to have two congruent angles, and those are going to be located directly across from those congruent legs. So I'm just pointing the arrows to where those congruent base angles are. So if AB is congruent to AC, then I know that angle B is congruent to angle C. The angle A at the top is my vertex angle. The next slide is going to be the converse of this theorem. So we're going to switch the order. So in the base angles theorem, we were given the sides congruent and we can prove angles are congruent. Now they're going to start out by telling us the angles are congruent. Given the angles are congruent, then you can conclude that the two sides, the legs, across from those congruent angles are also congruent sides. So if angle C is congruent to angle B, then side AB is congruent to side AC. All we did was switch the if and the then. We learned about converses back in Chapter 2. Next, we have some corollaries. And remember, these are always based on theorems. So they're both based. The first one's based on the base angles theorem, and the second corollary is based on the converse of the base angles theorem. And these are really common sense. So if a triangle is equilateral, then it's equiangular. So for example, if I give you a triangle and I've labeled all the sides as being congruent, this tells me that this triangle is equilateral. And if I have three congruent sides, then I also know I have three congruent angles, making this equiangular. Same thing on that converse. So the corollary to the converse of the base angles theorem, if you start out by being given a triangle with four congruent angles, making it equiangular, then I also know that the three sides across from all of those equal angles are also three congruent sides, making it equilateral. Let's try some examples. So it wants us to find the value of x on all three of these pictures. So let me go ahead and zoom in here so we can see example A here. So remember that when you have two congruent sides, the angles across from those congruent sides, which are called legs, are also congruent angles, and they're called the base angles. So if this angle is x, I also know that this angle will also be x. Now, I can go ahead and solve this without doing any kind of algebra. I'm going to do it both ways just by showing you what you could do mathematically. So when you're doing the homework tonight, you can either just show me your calculations. So I'm going to use my triangle sum. I know that the three angles of the triangle add up to be 180. So I'm going to take 180. I'm going to subtract the 30. And this tells me that I have 150 degrees left over for those bottom two base angles. So, and I know they're both equal. So I'm just going to take that 150, divide it by 2, and each angle, or x, is equal to 75 degrees. Now, if it asks you to write an algebraic equation, then what you would end up doing is showing me that it was x plus 30, adding the three angles, and setting it equal to 180. Combine your x's, and then subtract the 30. 2x equals 150. Divide by 2, and you can get x equals 75 algebraically as well. So just be aware, if in the homework it does not specify, if it doesn't specify to write an algebraic equation, just show me these simple calculations of how you're subtracting and then dividing, or whatever other operations are involved. Let's try the next one. Now, one thing to keep in mind is whenever they're referring to an angle in the picture, they're always going to have the little degree symbol. If there's no degree symbol, then they're talking about the sides of the triangle. So in this particular figure, for example B, this 2x minus 4 is the length of this side, and the x plus 5 is the length of this side over here. Notice we can use the converse of our base angles theorem, that if we have two congruent base angles, then the sides opposite them are also congruent. Now, this 2x plus 2 is here to confuse you. We do not need that expression. All we need are the two sides that are congruent, the legs, and because I know that these two sides are congruent, to solve for x, I'm going to set them equal to each other. I'm going to get my x's on the left side by subtracting this x, and then I'm going to add the 4 to get the constant to the other side, and x equals 9. All they asked for was the value of x. If they ask you to find the length of each side, then I would have had to plug it back in. So for C, you might look at this and like, what am I going to do here? There's no congruency marks or anything. But what I could do is find that missing angle that goes right here. And the way that I can do that is I can use my triangle sum. So what I'm going to do is I'm going to add the two angles that they gave me, 56 and 62. I get 118. I'm going to subtract that sum from 180 to find out that my missing angle is actually 62 degrees. So now let me get rid of my question mark. Let me add in that angle measure. So the missing angle is 62, making these two base angles right here, and then the sides across from them are the congruent sides. So the 42 and the x are the two legs, making x equal 42. So again, you may have to go back and do something that you may not think matters, but it did, because 56 and 62 alone wouldn't have told me which two sides were congruent. But as soon as I filled in that missing angle, I could see where the base angles were located, and then I could find my congruent sides. Now we're going to do two proofs. Again, this chapter is full of proofs, and we're going to use what we learned today. We're going to use our base angles and our converse of our base angles. So for this example, it's sort of like what you do in the homework where you're dragging and dropping. So they've given us the 4 statements we need. All we need to do is put them in the correct order and then also provide the reasons for each of the statements. So let me go ahead and set up my 2 columns. Come over here to the side. So I have my statement column and my reasons. So always remember, you're going to state your given first. And I was given that angle 1 is congruent to angle 2. And my reason is given. So that was D here. So this was number 1. So I'm going to go ahead and label my picture with this given as well. And then I'm going to go ahead and look at the diagram to see maybe where my second statement's going to come from. So angle 1 and 2 are congruent. So let me add in the congruency mark here. Also, when I view this picture, I can see I've got 2 pairs of vertical angles. And I know that angle 1 is congruent to angle 3 because these are vertical, and angle 2 is congruent to angle 4. Now, notice the congruency marks that were already there. I just matched the symbol that was already there. So my next statement is the vertical angles, and it's going to be the B. So I'm going to state that angle 2 is congruent to angle 4, and angle 3 is congruent to angle 1. And the reason why I can state this is because of my vertical angles congruence theorem. Now, if you notice, I've labeled 3 and 4 as congruent. So that's going to be my next statement, which is A here. So I'm going to state that angle 3 is congruent to angle 4, and my reason is substitution. And what I've done is, if you think about it, if you go back up here, and at the beginning we were given that angle 1 equals angle 2. So if I take this 2 out, and then I now put in a 1, just to show you how this is working. And then now if I go to my next statement, since angle 1 equals 4, I could take out 1, and now I can replace that with a 4, which is what I got for my third statement. So I kept substituting the original one into the second, and then the second into that second line to get my fourth line, or third line. Now that I have congruent base angles, I can state that OJ, or OK, is congruent to OJ, and my reason is because of the base angles theorem converse. And it's important that you include the word converse. Remember, the converse states that if the base angles are congruent, then the sides are congruent. And that is the end of that proof, because my last statement was C. That's what I wrote for 4. Okay, so I fixed those numbers under the reasons. So 4-step proof. So another proof, this time they didn't give us anything, so we got to do everything by ourselves. So let me go ahead and set up my statements and my reasons. So statements and reasons. So again, state your given. So M is a midpoint of AB, and the measure of angle 1 equals the measure of angle 2. And that's given. And I'm going to label my picture with this given. So 1 and 2 are congruent. I also was told that M is the midpoint. And I know by definition of a midpoint that it's going to split segment AB into 2 equal pieces. So I'm going to add a congruency mark from A to M, and then another one from M to B. Now, what I just labeled in the picture, I now have to write in the proof. So that'll be my next statement. I'm going to state that MB is congruent to MA, and those were the red marks I just added in, and that reason that I can say that is definition of midpoint. The next thing I'm going to state is that since I have base angles that are congruent, I could also state that the sides or the legs of my triangle are also congruent by the base angles converse. Because what I'm talking about is this isosceles triangle right here. Because if I have congruent base angles, then my sides opposite them are also congruent. And that'll be my next statement. And I can state that AC is congruent to AM. And the reason why I can state that is because of the base angles theorem converse. And now notice you got the same 3 red markings. So now I can actually go to what I was asked to prove, because I've already marked it here. AC is congruent to MB, and that reason is transitive. Or you can say substitution here. When you're doing the homework, they'll be looking for a transitive. Because notice what's happening here is these MAs, and here it's sort of backwards, AM and AM cancel, and then that's how you can go from this equal to this, which is your last statement. And that is it for the notes on section 5.4. You have the big ideas homework assignment. I also posted on Canvas a quiz review for those of you who want to start looking at it. It's just a PDF, and then I also posted the answers in the same assignment. If you notice in the description, it says NG. It's not graded. It even says in the assignment in the description, do not submit to Canvas. But it's for those of you who are going to start looking at it over the weekend to get ready for Tuesday's quiz. On Monday, we will review. I will give you more specifics about the quiz, and then we'll do some type of review in class on Monday as well.